about how the environment is affecting the polar bears. And so continue to enjoy your meal. And we're going to listen to Larry. And please go by and check on the silent auction items as well. He'll keep talking while you look. And we'll proceed with that. Larry Best.
Good evening, everyone. Thank you very much for being my captive audience for tonight. I've actually given this before. I gave it at a February meeting, but it was a pretty small crowd. I apologize in advance to the people that had to sit through this once more, but I can tell them that a lot has changed, and it's not necessarily good news, and I want to try to capture that in the talk that we're doing shortly. We'll try to keep this to about a half hour. And you know, if you have any questions, let's talk through some questions at the end if you have any. Last time I just started talking, and then everybody stopped and said, "Well, why are you doing this? You know, who are you, and why are you talking to us?" So let me just quickly introduce myself. I was born in Texas, raised in Alabama and Florida. And left the South 45 years ago to go to West Point. I finally got back to retire 3 years ago. Everybody talks differently. I just don't get that part. But you know, at West Point, they really emphasize public policy, a commitment to what's important to the security of the nation, what factors, both immediate and long term, could have an impact on society. So I developed a deep interest in public policy and have been following that for a long time. It's also a science school, very much of a science school, and I'm a technical person. I wrote a book on a technical topic, and I was essentially a management consultant working for PricewaterhouseCoopers, if anybody's ever heard of them. My last job was actually working in New York City. I was a management consultant. Did that for many years. I'm very happy to be doing this instead, I got to tell you. But, and I do have a couple more reasons that I'm very interested in the topic of climate change, but I don't want to get to those until the very end. So we'll revisit the question of exactly why I'm so engaged by this particular topic. We're going to talk about polar bears, but really on a larger context, we're going to talk about the whole topic of climate change and why should we care about it, what can we do about it, and what do we need to do about it. Okay, so I'd like to start with a quick video from a recent show called Nature. I'm sure some of you probably watching. Not exactly about the polar bears, but it did have some pretty interesting footage about the polar bears. So let me quickly switch over to this, and hopefully everybody could hear. Hopefully it doesn't get messed up.
Seal pups use the ice as a platform for resting and being fed, enticing the largest land carnivore on Earth out across the frozen sea, the polar bear. All through the winter, it stalks hunting grounds 1,000 miles from land. Without the ice, the polar bear could not survive here. The ice is home. With a solid surface beneath them and a strong sense of smell, polar bears have a great advantage over prey that sooner or later must come up to breathe. It's the ice that lets them close in on their quarry. Attacking from above, they smash through to get to seals hiding below.
Anybody want to say?
Good hunting at this time of the year is essential to surviving clean Arctic summers. All animals that live here rely in some way on ice. It's not just the polar bear. But ice is becoming a fragile player on the Arctic stage. This is one of the fastest warming regions on Earth, and it's melting at a breathtaking rate. Large parts of the Arctic that were once frozen all year are now free of ice in the summer. There are many opinions on how much this place is changing, but it's well documented that in the last 30 years, there's dramatically more water and less ice each summer.
So just to summarize the video, the polar bears really need that ice, and without the ice, they can't survive. I mean, they're 1,000 miles from land on the ice, and they can't they can't swim 1,000 miles. So, what exactly is causing the Arctic to melt so fast? Hopefully you can see this. This is actually from NASA, and it shows carbon dioxide levels over the last about 650,000 years. What you can see by the pattern is that the 1950 level was the highest that it's been in over 500,000 years, and that the level going since 1950 is going straight up in essentially a straight line. Now, nature doesn't do straight lines, so that basically means that mankind is dumping carbon dioxide into the atmosphere at a tremendous rate, and it's causing the levels of this greenhouse gas to increase enormously. And what it's doing is causing temperature to rise. This is essentially two views of global temperatures over the last 135 years, which is about as long as mankind's been able to keep reliable records. Basically, what you can see is that it's been over a century since we had the coldest year on record, and it's been half a century since a year that was below the 20th century average. 2014 was the hottest year ever recorded. Now, you have some people that say, well, it's not so bad because warming has leveled off, but they base that on a false premise, which is this little spike right here in 1997-1998, which was what's called an El Nino event. It was one of the greatest El Nino events ever recorded, and it raised global temperatures by an absolutely stupendous amount. If you think about the amount of energy it takes to raise the surface of the Earth by 1 degree, it's really a huge, huge amount of energy. So by comparison, 2014 is a little bit higher. The thing is, 2014 and many of the other years that we've had recently were weak El Nino years. So what that means is the very next strong El Nino year will blow away the temperature records. But it's very clear that a clear pattern, CO2 is rising, and in lockstep with the increase in CO2, we get increase in global temperatures. And what that's causing is, among a lot of things, is that the Arctic sea ice that the polar bears rely on to hunt is declining precipitously. And once again, nature doesn't do straight lines, so it's going up and down, but it's a very clear pattern that it's going down. And people that study polar bears have made a very strong correlation between the state of the Arctic sea ice in a particular area and the ability of the population of bears in that area to survive. One particularly bad area from the standpoint of the polar bear is the Beaufort Sea off of the north coast of Alaska. A big bear population there. It's a big loss of sea ice, and between 2001 and 2010 there was a 40% population decline. I mean 40%, that's a lot of bears. And more ominously, the polar bear cub population is drastically falling. You see only 2 of 80 cubs survived, and a very simple reason, that as the ice retreats from land, the polar bears have to swim miles and miles to get to the ice, and the cubs can't swim that far, and the mothers can't help them. So you get an enormous number of polar bear cubs that actually drown as they're trying to follow their mothers out to the sea ice. And the prognosis is not good at all. If you look at the decline in sea ice over years and projections going through the end of this century, we start with a lot of sea ice covering the entire pole, and by the end of the century it's going to be this tiny little piece just north of Greenland. So basically what that means is that polar bears are in deep, deep trouble. The ones where the sea ice has already declined are already in big trouble, and all of them are going to be in very, very deep trouble, certainly by the end of the century. And it's been projected that all polar bears will be extinct outside of zoos by that time. And the reason is they're going to starve to death. What you see here is a picture of a polar bear desperate for food who is raiding a rookery of seabirds. And unfortunately, for the polar bear, it takes a lot of energy to do that. And most times, that is unsuccessful. They waste a lot of energy, but they're not able to actually get any food out of it. So this is a fairly common occurrence. I actually have a video of this, but it was too heartbreaking to look at. It's a polar bear eating seaweed because it's dying of starvation. This is what a polar bear will typically look like during the summer months, which are the really bad months for the polar bear because the ice is all melted, and they pretty much have to rely on the fat reserves that they've accumulated over the winter. And here's a picture of a typical polar bear cub, with the incredible mortality rate that you see. So essentially the polar bears are in deep trouble. But why should we care about that? Well, there's a real big reason to care about that, because we're in deep trouble too because of the same things that are affecting them. They're essentially the canaries in the coal mine. We're hearing about their plights first because the Arctic is the area of the Earth that is warming the fastest. And it's a pretty straightforward explanation as to why that's the case. When the Arctic is covered with ice, the sunlight bounces off of that ice and goes right back into outer space. But as the ice melts, it gets captured by the warm polar ocean, or the warming polar ocean. So it's an exponential effect. So as the ice melts, more sunlight gets captured, and that melts more ice, and you get a vicious circle. Now, one thing we have to care about a lot is methane, which is the scientific name for natural gas. It turns out that there is a huge, huge, huge amount of methane that's frozen in the Arctic. There's 4 different ways that methane is sort of captured. It's in the water, it's in the land, there's hydrates, there's all different kinds of ways of methane. Now, we're familiar with methane because of fracking. In the U.S., the methane is deep underground, and we use fracking to get it out. Well, in the Arctic, it's not deep underground, it's sitting right on top of the ground, but it isn't released because it's frozen. Well, what happens is as the Arctic tundra starts to thaw, this methane gets released, and you can actually, you can actually create a little hole and light a match, and it'll flame up like this. So why should we care about methane? Well, it turns out that methane has a greenhouse gas potential 21 times that of carbon dioxide. That is, if carbon dioxide can trap X amount of heat, methane can trap 21X amount of heat. So, and if you look at the Arctic, you know, you have northern Alaska, you have northern Canada, you've got the Scandinavian countries, you've got Siberia. So a huge amount of real estate that has been frozen for millions of years is suddenly getting thawed out, and it's releasing one heck of a lot of methane, which has a tremendous greenhouse gas potential. And so there's a real danger that we might reach a tipping point where the global warming, the effects of climate change due to trapping of heat by greenhouse gases is so pronounced that it runs away and you get exponential effects. So we can actually, these are the extremes that you see, are the things that happen with climate change. They were theoretical 50 years ago, and now we're seeing them in the news pretty much every day. You know, extremes of weather, desertification, let's say that 10 times. You know, we look at the news on what's going on with California. They've been in a tremendous drought for 4 years. A study just came out that predicted that the U.S. West is in for a very long period of severe drought. Acidification. I happen to be a scuba diver. I got my certification in 1970 at West Point. And so I dive relatively frequently. And I've been able to see it when I go to the Caribbean and other places. You can actually see the reefs dying because of the acidification of the, and it's heartbreaking. I go to places, I've been to Cozumel 5, 6, 7 times. Most recently, it was horrible. I mean, everything was brown. The reef fish were sparse. The corals were covered with mucus, where before they had beautiful colors. It was heartbreaking. Mass extinctions. There's a lot of talk among scientists about a fifth extinction event. In the past, in Earth's history, there have been 4 great extinctions, and now they're talking about the anthropogenic extinction, because the number of species being lost due to their habitats changing is accelerating. There was an article in the New York Times a couple days after I gave this talk last to the Democratic group there that talked about how extinctions are accelerating faster than expected. And also sea level rise. And I want to talk about sea level rise in particular, because just as one example, we don't have time to really explore all of these. Let's talk about sea level rise. Now, it's a subject near and dear to my heart because I grew up in Tampa, Florida. 6 feet above sea level, where you can dig a hole and watch it fill with water. So it turns out that about 90% of the water, the fresh water in the world, is in 2 places. It's in Antarctica and it's in Greenland. And within Antarctica, it's in 2 places called the West Antarctic ice sheet and the East Antarctic ice sheet. And you can see where most of the water is here. It turns out that if you melt all the ice in the world, you get about 160 feet of sea level rise. So about 18 feet of that comes from the West Antarctic ice sheet. And that's been in the news lately. Scientists have concluded that it's inevitable that the West Antarctic ice sheet will destabilize, that it will essentially collapse. It's essentially undermined by the ocean. It's sitting on top of islands. This is not solid land. It's actually a series of islands. And what's happening is the ocean, the Southern Ocean warms, it is melting the ice here, and there's a real chance, many scientists have actually predicted that what's going to happen is that this is just going to slide off one day without warning. So the sea level rise from the collapse of the West Antarctic ice sheet, which I'll remind you is inevitable, that sea level rise could be very, very fast, in the order of weeks. And there isn't in the record, in the historical record, there are situations where sea level rose very, very fast in a matter of weeks as opposed to years. Now, the big question is how long is that going to take? But it's not. There's no debate that will happen. Now, in terms of Greenland, that similarly is melting very, very fast. And if you look at what scientists say about both Greenland and the West Antarctic ice sheet, is that the melting is happening faster than expected. You know, they had models for what they expected in terms of melting, and what they're seeing whenever they go to, you know, when the season changes and they go back there again, like you know, in the winter they go to Antarctica, in the summer they go to Greenland. When they get back there, they find out that the melting has been happening a lot faster than they expected. So if you put those two together, you essentially got 40 feet of sea level rise. Well, it may not sound like much if you're at the 820 line like we are, but if anybody's here from a place next to the ocean, 20 feet means that there's no beaches anymore, no ocean beaches in the world, and it takes 1,000 years for a beach to form. So it's not like you're going to have less of a drive to get to the beach. There won't be a beach because it takes 1,000 years for a beach to actually happen. And no harbor facilities, no port cities. That's a real catastrophe. If you think of our grandchildren without, with New York underwater, with London underwater, with every port city in the world underwater, that's a pretty drastic situation. And now we're going to talk about the East Antarctic ice sheet. That's the one that everybody felt pretty good about because that's where most of the water is. And it turns out that just a couple of weeks ago, they found out that a huge chunk of the East Antarctic ice sheet is melting very, very fast. Something to do with volcanic underneath. So it's starting to act up when before it was considered to be pretty safe. So this is just with regular CO2, which is accelerating. I mean, the amount of CO2 we're putting into the air is actually growing at an accelerating rate, and that doesn't even count the effects of methane, with its 21 times impact on heat trapping. So basically, we have a pretty dire situation. But here's the good part. It turns out that it is entirely possible to do something about it. For example, there was an article in the News Sentinel, the local paper here, not too long ago, just a couple of months ago. TVA has reduced sulfur dioxide by 95%, nitrous oxide by 91%, and carbon dioxide by 32% since 2005. That's pretty astounding that TVA was able to do that, 32% since 2005. The Europeans take this pretty seriously. I'll talk about why in just a moment. But they're looking at 20% reductions, and they're well on track to meet those reductions. There was an article not just a couple of weeks ago interviewing Al Gore. It turns out that the projections about the cost effectiveness of some of the renewable technologies, for example, solar and also wind, it turns out that predictions were made 15 years ago about how cost effective they would be. In the case of solar, those projections have been beat by 50 times. So in other words, solar is now 50 times more cost effective than it was projected 15 years ago. And wind is also on the nature of 25 times more. It was estimated how much wind power we have, and that's been exceeded by 25 times. So it's entirely possible if you have if you care to do something about it. Now, I don't know if anybody has any European friends. They probably do. We used to work for an ex-Royal Marine when I worked at PricewaterhouseCoopers, and he kept in touch with his friends back in London. And basically, what he said is that it's extremely politically incorrect there not to care a lot about climate change. That people talk, they have dinners like this, and they talk with each other about what they're doing to reduce emissions, and so they really care. Now, why do the Europeans care so much? Well, it's pretty straightforward. Europe would be uninhabitable if the Gulf Stream were to pause. And if you think what the Gulf Stream is all about, it's basically it's a warm water that comes out of the Caribbean. It goes over and makes Europe livable, because London is the same latitude as Alaska. It's way, way north, right? So it warms up, and then it gets to the Arctic, and then it's cold in the Arctic, and all that water, all that warm water is given up its heat, and it sinks to the bottom of a very, very deep place, an abyssal plain. And as it's sinking, it acts like a pump. It pulls the water out from the warm part. So essentially, the cold Arctic is a pump that allows the Gulf Stream to function. And if the Arctic suddenly stops being cold, that pump could stop very fast. And the Gulf Stream is not always operated. It stopped in the past. So Europeans know that they'd be in a world of hurt if the Gulf Stream were to stop. Now, U.S., there are a lot of places that have made significant progress, but it's not being driven by the federal government. I mean, if you look at TVA, it made gains because of a lawsuit. A lot of businesses, and as a management consultant, I would talk to a lot of businesses, and they're taking it very seriously. They're using going green as something they can advertise, because the executives they work with think that's a good thing. A lot of state and local governments have shown a lot of leadership. But the basic problem we have in the U.S. is that one of the two political parties, and I'll let you guess which one, has made denial of climate change a basic plan. And that's a really critical issue, because the United States is the leader of the world. It's the leader of the world in technology. It's the leader of the world in how we live. How we live essentially influences how people live around the globe. This is, if any, what we need right now is a Manhattan Project. We need a big investment in the technology so that when these developing countries come up, rather than building coal plants, they can go to a more cost-effective technology that also has the benefit of being green and clean. So just in the same way that they have jumped straight to cell phones and not bothered to wire their entire countries with overhead wires, that's the solution to making sure that developing countries don't go through what we did and dump huge amounts of greenhouse gases. So why does the Republican Party essentially, why have they embraced this particular plank in their platform? And it's pretty straightforward. I mean, if you look at people like the Koch brothers, I mean, they make enormous profits by treating the atmosphere as a free dump for essentially tens of billions of tons of industrial waste greenhouse gases. They don't pay a penny, to put huge amounts of carbon pollution into the atmosphere. And they're happy with that situation. They don't want to pay. And so what they've done is they do things like the Heartland Institute. It's the 21st century version of the Tobacco Institute, that organization that said scientists say smoking is good for you. And literally some of the same people that used to work there are now working in institutions like the Heartland Institute, where they're getting megabucks the amount of money that's going to universities to fund